Alrighty, so today we're going to be looking at sketching a cubic, showing all information. In this case, for a cubic, we want to know all of the intercepts and the turning points. And for finding intercepts, we can do that algebraically for some cases. We can factorize. But for finding turning points, we currently do not have a strategy whatsoever. So we look towards our calculator friend. And so we actually do have all of the facilities within the calculator to, in fact, actually go through and find everything we're looking for. So I'm just going to quickly go through and have a go at doing this. So once we've actually got our function in here, we can click the draw button. And depending on how you've set up your axes, it's going to look very different. So let's just get our view window to this standard view window. So Shift F3 to get the view window option, and then F3 again to get the standard. Standard's just a good way of kind of gauging what it actually looks like. So you can see that there appears to be 3 intercepts on the x-axis, one here, and one here. And we've also got one on the y-axis about here. We've got a turning point around -1 on the x-axis, and we've got another turning point around 2 on the x-axis. So let's actually get the actual details down. So G-solve, let's start off with our roots. So for each of these, we can just jot down. Now for these, too many decimal places is going to hurt us. So let's start with a good old -1.620. That's our first x-intercept. Alrighty, so it looks like we should have 3. So click right, find the next one. Yep, here's another decimal continuation. So 0.62, 0. And lucky last is just 3. Okay, so we don't need to do much rounding for 3, so we'll just put 3, 0. And there we go. So those are my x-intercepts. Next up is the y-intercept. Alrighty, Shift G-solve, y-intercept, and it's just 0,3. And as usual, we're always only going to have one, at least for functions, we're only ever going to have one y-intercept. Otherwise, it would fail the vertical line test. So now, we need to find the mins and the max. So you can see there's one maximum up here because it's like a frowny face, so it's the highest point, and then we've got a minimum down here. So let's use Shift G-solve, and let's find that maximum. Alrighty, so the next one is a max, and it is at -0.67, 4.48. And there should also be a minimum. I mean, you can click the left and right arrows, but you'll see that it'll load and then it'll just stop. Minimum. Once again, let's click left and right. Oh, that's nice. The minimum's actually a nice number. So we've been given 2, -5. Okay, so these are the points that we have been given. Now it is our time to draw them. So as you well know, this is about to get quite ugly, so I'm just going to try my best to keep it as neat as possible. Vertical line, hump, down and up, trying to follow the actual picture as best as possible. And now I need to mark all of these interesting points. X, Y. So this first maximum, that is my -0.67, 4.48. I've got this x-intercept here, that's my first one, -1.62, 0. I've got my next one, which is at 0.62, 0. And I've got my last one, which is at 3, 0. And I've got my y-intercept up here, which is 0,3, and that just leaves me with my minimum, which was at 2, -5. And there we go. That is my picture of that function, where not a lot of actual calculations need to get done. In fact, basically nothing. This is essentially trying to copy a picture off a calculator. But this is really, really useful because that means we know where peaks are, we can find out where valleys are, we can find out when it hits the x-axis or the y-axis, all without having to do any algebraic work. So it can save a lot of time. Alrighty, so that's it. I'll see you in the next one. Goodbye.